We are meticulously analyzing something truly remarkable that appears to be unfolding with 3I Atlas. Multiple independent observatories worldwide are reporting continuous velocity changes that seem fundamentally inconsistent with natural expected hyperbolic trajectory patterns. When an object initially enters our solar system on what astronomers classify as a hyperbolic orbit, the underlying physics are quite straightforward. The object possesses excess velocity beyond the minimum required to escape the sun's immense gravitational influence following its perihelion passage. It should predictably continue outward, eventually returning to deep interstellar space. This is the expected, well-understood behavior based on celestial mechanics that humanity has refined over centuries. However, 3I Atlas appears to be systematically deviating from this expected path. Before I delve deeper into the analysis, I need you to engage with this extraordinary data. Tell me which country you're watching this broadcast from. Drop a comment below. Please like this video. And most importantly, subscribe to this channel. This crucial interaction helps us accurately gauge the global reach of these critical observations and discussions. And here's a direct, provocative question for you. Do you personally believe that interstellar objects could potentially be technological in nature? Write yes or no in the comments section. The detailed trajectory calculations emerging from the Jet Propulsion Laboratory, JPL, show a phenomenon that urgently demands comprehensive explanation. Over an approximate period of 11 days, the object's velocity relative to the Sun appears to have consistently decreased by roughly 2.8 kilometers per second. Now, it is crucial to acknowledge that measurement uncertainty is inherent in all astronomical observations. We must rigorously account for all potential errors in our highly sophisticated data collection methods. However, when multiple distinct and independent astronomical facilities report highly similar findings, the overall probability of a widespread systematic error decreases very significantly. If this observable deceleration continues at its current steady rate, the mathematical implications are starkly clear. 3I Atlas might be on the verge of establishing a permanent residence within our solar system. The observed velocity numbers are particularly striking. 11 days ago, initial tracking data suggested an excess velocity of approximately 4.2 km/s. 8 days ago, that figure appeared to drop to 3.1 km/s. 5 days later, it had fallen to 1.9 km/s. Current refined data indicates an excess velocity of roughly 1.4 km/s. If this concerning trend persists, we're looking at zero excess velocity in approximately 18 days from the time of these latest measurements. Zero excess velocity means, by definition, the object becomes gravitationally bound to the Sun. It would no longer possess sufficient speed or kinetic energy to escape the Sun's gravitational field. From a purely fundamental physics perspective, that scenario represents a fundamental and irreversible change in the object's orbital classification. But here is the data point that concerns me most deeply as a practicing scientist. The projected resulting orbit parameters suggest something even more precise and specific based on current sustained deceleration profiles. The resulting elliptical orbit would have an aphelion, farthest point from the Sun, around 1.5 astronomical units, and a perihelion, closest point to the Sun, near 0.9 astronomical units. For critical context, Earth orbits at approximately 1 astronomical unit from the Sun. This means the object's projected final orbit would cross Earth's orbital distance. More significantly, the orbital period might establish what astronomers term near resonance with Earth's orbit. The object would therefore encounter our planet's vicinity repeatedly on a highly predictable regular schedule. Now, let me be explicitly clear about the requirements of the scientific method here. We are currently observing an objective phenomenon. We are calculating and refining trajectories based on all available data. We are projecting possible mathematically sound outcomes. What we cannot yet determine with absolute certainty is the mechanism causing this striking deceleration. Natural processes could, in theory, potentially explain some velocity changes, solar radiation pressure, outgassing from volatile materials, though no coma is observed, or complex gravitational perturbations from planetary encounters. These remain all possibilities that require thorough objective investigation, but the sustained and continuous nature of this apparent breaking raises profound questions. The energy requirements for such a massive velocity change are truly substantial. If this deceleration is the result of active propulsion rather than passive natural effects, we are observing technology operating on principles that far exceed our current engineering capabilities. Let me walk you through precisely why this capability represents something truly extraordinary from an engineering perspective, specifically concerning the necessary total velocity change, or delta V. The delta V required here, the total velocity change needed to transition from a hyperbolic escape trajectory to a gravitationally bound orbit, involves removing approximately 4 km/s of velocity. To put that monumental task in human context, the entire Apollo missions required roughly 3 km of delta VI just to escape Earth's gravity and successfully reach the Moon. What we are potentially observing with 3I Atlas exceeds that feat, and it is happening continuously over a period of weeks rather than in short, high-thrust bursts. If we are looking at some form of nuclear propulsion or an exotic system we do not currently understand, the engineering sophistication would be far beyond our present capabilities. Either scenario, natural or artificial, suggests an intentional, highly controlled modification of trajectory for specific unknown purposes. The timing of this behavior matters significantly. The apparent deceleration began shortly after 3I Atlas completed its closest approach to Earth at 0.885 astronomical units. During that critical pass, any sophisticated observing system aboard the object would have gathered incredibly detailed data about our planet, electromagnetic signatures, the presence and patterns of satellite constellations, industrial activity levels, and urban development patterns. All of this information would be perfectly apparent from careful external observation. Then, immediately following that close approach, the continuous braking behavior begins. The temporal correlation does not definitively prove causation, but it does strongly suggest a working hypothesis worth investing resources to investigate. What if the decision to decelerate and establish orbit was directly informed by what was observed during that Earth flyby? Consider what objective external observers would accurately detect about our current civilization. We are clearly technological. Radio emissions, organized satellite constellations, evidence of large-scale energy use. But we are also demonstrably early stage in terms of spacefaring capability. We maintain a presence only in low Earth orbit, but have not established permanent settlements beyond our planet. We are also observably divided, multiple competing nations rather than unified planetary governance. All of this highly critical information would be readily apparent from careful external observation. From a hypothetical anthropological perspective, this represents a fascinating moment in a civilization's development. We are advanced enough to be clearly technological, but not yet mature enough to be a stable, unified, spacefaring civilization. If you are studying intelligent life across the galaxy, this is precisely the developmental stage that warrants the closest, most sustained attention. Or perhaps what was observed raised concerns rather than curiosity. The existence of nuclear weapons, the clear signs of environmental degradation, or rampant geopolitical tensions, these patterns might potentially trigger specific protocols for monitoring a potentially problematic developing civilization. I am certainly not claiming to know which interpretation is correct. I am merely outlining the complete hypothesis space based on the limited available observations. The detection methods we are currently using show no visible exhaust plume, no large thermal signature consistent with known rocket engines, and no evidence of mass being expelled that our sensitive instruments can detect. Yet the velocity changes appear unequivocally real and sustained. Whatever propulsion system might be operating uses physical principles we do not observe or replicate in our own technology. That fact alone represents revolutionary physics. But in the current context, it is simply another data point indicating how limited our understanding might be. The central question we face is not just what 3I Atlas is doing, but why. And that leads us to something critically important. Why would an interstellar object choose to remain permanently near Earth rather than continue its centuries-long journey? This question has no definitive answer yet, but we can construct several reasonable hypotheses based on what we ourselves do in similar circumstances. Consider the first possibility, an extended observation mission. If the object came specifically to study our solar system and, more specifically, Earth, remaining in a stable orbit provides ongoing observational capability rather than relying on a single quick flyby. This is exactly what we would do if we sent a probe to another star system and discovered an interesting planet. We would stay and study rather than pass through once and leave. The second hypothesis involves establishing a communication relay or monitoring station. If 3I Atlas is part of a larger network reporting back to some distant civilization, maintaining a fixed position near an interesting discovery makes strategic sense. A technological civilization like ours represents a significant finding worth monitoring long-term. The object could serve as a permanent observation post, a communication node, or a continuous data collection platform. From this objective perspective, staying is not unusual. It is simply logical mission architecture. The third possibility is pre-contact positioning. If eventual communication or interaction with humanity is planned at some unknown future point, having a probe already in a stable orbit nearby provides immediate presence when that contact is initiated. Rather than sending another mission that takes decades or centuries to arrive, the probe is already perfectly positioned and ready. This implies immense patience, a willingness to wait for the right developmental moment in our civilization's progress before revealing its true purpose or initiating dialogue. The fourth hypothesis is more concerning: strategic positioning for monitoring a potentially problematic civilization. If the assessment of humanity raises serious concerns about our developmental trajectory, our behavior patterns, or our potential to become a threat, maintaining a close presence provides the capability to respond to future unforeseen situations. I am emphatically not suggesting hostile intent, but monitoring a civilization that possesses nuclear weapons, demonstrates deep territorial conflicts, and shows clear signs of environmental mismanagement might be considered prudent from a detached external perspective. The fifth and potentially most significant possibility is preliminary positioning before more direct interaction. If staying represents the very first step in a larger plan that involves additional probes, an expanded physical presence, or even direct intervention in Earth affairs, then orbital insertion would be the logical opening move. You establish presence, you observe local responses, you accurately assess readiness, and then you proceed with subsequent phases based on that assessment. The enormous challenge we face is scientifically distinguishing between these possibilities with only the available limited information. We can observe what 3I Atlas appears to be doing. We can precisely measure the deceleration. We can calculate the projected orbit, but we cannot determine intent. We cannot access the decision-making process behind these ongoing actions. We are watching something with apparently superior capabilities make choices that directly affect us, and we are essentially powerless to influence those choices or fully understand them. This pervasive powerlessness represents the core issue that concerns space agencies worldwide. And the situation is about to get significantly more complicated. When this object actually enters a bound orbit, it raises questions we are profoundly and globally unprepared to answer. Another important problem is that NASA and other space agencies face a problem with no precedent and no clear international protocol. If 3I Atlas establishes a permanent orbit near Earth, it immediately becomes an uncontrolled presence in our orbital space. It can continuously observe all our activities: satellite operations, spacecraft launches, military exercises, communications infrastructure. Everything becomes visible to whatever observational capabilities the object possesses. More significantly, it could potentially deploy additional assets: smaller probes, sensor packages, capabilities we cannot currently imagine. And there is essentially nothing we could do to physically prevent any of that. Some have suggested attempting a more forceful communication, powerful radio transmissions directed at the object, requesting it to leave or explain its intentions. But consider the leverage problem. We can ask, certainly, but we cannot compel. If it chooses to stay despite our explicit request, we've accomplished nothing except demonstrating our profound lack of control over the situation. Others argue for a demonstration of capability, showing that we possess defensive systems, advanced weapons, and technological sophistication. The theory is that this might discourage unwanted presence, but realistically, any civilization capable of interstellar travel is unlikely to be impressed or intimidated by our chemical rockets and nuclear weapons. The technology gap is simply too wide to bridge with threats. International coordination adds another layer of complexity. Every space-capable nation is tracking this object. Russia, China, European nations, India, Japan, all are reaching similar conclusions about the trajectory changes. But national interest creates significant tension in response coordination. Some nations see potential opportunity if contact eventually leads to technology transfer. Others see a potential threat requiring immediate defensive preparation. Unity becomes difficult when both fear and ambition run simultaneously high. If China, for example, possesses additional intelligence about the object's systems or capabilities, that creates information asymmetry. Other nations work with an incomplete picture while one potentially knows more. This is frustrating from a coordination perspective, but entirely consistent with historical patterns of nations protecting strategic information advantages. The public communication challenge may be the most difficult aspect of all. How do you inform the general public that an object of unknown origin with apparently superior technology has decided to establish a permanent presence near Earth, and our ability to influence this situation is essentially zero? NASA's cautious approach so far has been releasing trajectory data without explicitly stating the dire implications. They are making technical announcements about continued observation without stating directly that the object might be braking to stay. This strategy buys precious time for internal planning and international coordination, but it cannot last indefinitely. Amateur astronomers are actively tracking 3I Atlas. Independent researchers are meticulously calculating trajectories. The deceleration is becoming obvious to anyone doing careful analysis. Within days or weeks, the final conclusion will become unavoidable and public. And that's when everything changes. Stay with me, because what I'm about to explain about the critical timeline ahead will show you exactly how close we are to a fundamentally different reality. Here's what makes this situation critically urgent. 3I Atlas will reach zero excess velocity in approximately 18 days from the most current measurements. Let me be precise about what that specific transition means. Zero excess velocity indicates the object no longer possesses sufficient speed